All good now.
Yes.
Okay, perfect. Shall I start now? Okay, wonderful. So, good evening, everyone, or depending on where in the world you are, good morning or good afternoon. I'm Ron Fernandes, and our topic for today's conversation is artificial intelligence, policy practice, and professional opportunities. The practice, of course, obviously refers to our interest as managers, as administrators, and of course, the professional opportunities would be targeted towards current students of IRMA or recent graduates from IRMA who are trying to figure out what this technology means for their careers. And I hope that by the end of this talk or conversation, you'll see that I have provided some useful resources for you guys as well. But before I begin, I just wanted to, and this doesn't need to be typed thing. You can just put your audio on because we have just a few people. Like, what are your expectations? Like, I mean, what do you think of AI? Have you worked with it? What would you be expecting from this talk? And then I can, correspondingly, direct my talk towards answering those questions. Uh,
Shall I start?
yeah, go ahead, Chidambaram. Yes.
Okay. So this technology, artificial technology, is going in a very, very fast manner. Means the development of
Yes.
artificial intelligence is beyond the
Yes.
imagination. It's going.
Yes. Yes.
But whether the policymakers are prepared to take this, or what is that to be done to prepare the policymakers at the state, at the national level, at least in India, what should be done so that they use the artificial intelligence for
Yes.
governance. So
Yes.
how, because many of these politicians are either school pass outs or just college pass outs. They are not
Yes.
technocrats. They do not know
Right.
much. So
Right.
what is that? What is to be done? What
Sure.
actions should be taken to use this monster, I will say. So to
Yeah.
if you are
Well,
not prepared,
yeah.
so
Yes.
it will take you to your wrong place.
Yes. You have to
So
understand the
this
technology. I
was
get it. Sure.
exactly, yes,
Yeah.
yes.
Got it. Yeah, I will be addressing
Go
that.
ahead.
I have a specific slide just for that. I see
Okay.
Shankar D. Shankar is here.
Um,
Shankar, would you mind enabling your audio and sharing what you would expect from this uh, conversation? I don't. Yeah.
yeah. Sorry, having an issue.
And there's also a Zoom user. I don't know who that is. Is that someone? If you can just mention your name and okay. I say Shankar says he has some issue with your mic. Okay, I understand. If you have any specific questions, I mean, it'll be a little more painful for you, but if you can just type it out and message everyone, and that should be fine. So my usual convention when I have these discussions, at least when I was teaching at DePaul, was to if there are any clarifying questions, you can stop me at any point during the slides and I can clarify. And then I've kept a full, let me say at least 20 minutes, 25 minutes for discussion at the end as well to address any questions that you may feel have not been addressed. So as I said, I'll be talking about artificial intelligence or AI as it's known as, and its implications for policy, for management practice, and for professional careers that we're thinking about. Let's start first with just briefly defining the monster as Chidambaram refers to it, but I would not use that term. I would just use it a more value neutral term, that it's something different, something that we are very unfamiliar with. When ChatGPT first came out in 2022, people were so amazed with what it could do. and that they were making wild claims about consciousness and sentience, and which had never been made of. I mean, we've been working with technology. We are at the fag end of the information age, right? Which is 60 to 70 years of technology, computers, internet, all of that, but social media. But intelligence was never attributed to computers. Intelligence was always our domain, right? We as human beings. So, what AI is basically is now where you have computational systems that perform tasks that were traditionally associated with human intelligence. That is where you expected, a human being to solve a problem in a certain way. Now you just feed that problem to the system, and it comes out with an answer, and it's a fairly compelling answer. It seems to pass the Turing test, which is one standard that people use. That can a normal person distinguish between those two outputs that come out, like what a human being is saying and what the system is saying, and it has become nearly impossible to distinguish between. You don't know whether you're talking to a human being or to this AI system, as it's called that. But what is important for me personally, and to emphasize that this is that uh, it's a product of human intelligence. It's not. People think of artificial intelligence, and that's the problem, is that they think, oh wow, it's something alien, right? It's something that's come from above, and but human beings have created it. Our intelligence created it. We decided the algorithms, we designed the chips, that are able to do this large scale statistical processing, of data to exhibit, where these systems now exhibit human intelligence. They're not intelligent, but they show signs, they exhibit, they mimic intelligence, so to speak. But it's a product of what we've created. Right now, we might disagree, like nuclear energy. We might say, well, has nuclear energy helped mankind? And there could be huge discussion about that. But that's pretty much true of any technology, right? So I'm saying, let's look at this technology too from that perspective, in a long line of technologies that human beings have created to make our lives easier. We've been creative, we've been innovative, we've worked with nature, and we've created these technologies. And in general, they've been incredibly beneficial, except, I mean, like with nuclear energy, you could wipe out the whole, earth with the technology if, bad actors get to it. And AI could be that kind of technology too, in its extreme case, if it succeeds. But, we are far away from that. It's not as clear how it would do that as it would be, say, with nuclear energy, right? So it's very clear, you split the atom and enormous energy is released. And if you can control that release, you can destroy the earth, a certain that. So that sort of thing. So it's really important, I think, to distinguish hype from reality. And so I just happened upon this video. It's called the AI Doc, or How I Became an Apocalyptomist by Dan Roher. And it's on Geo Hotstar, and it's associated, you'll get it on ATEL and others as well, because they tie up with them. So if you really, it's a nice video, because it really gives you a nice perspective on the whole issue, especially from an individual point of view. Answering very specific questions like, okay, with AI now doing what it can do, what's going to be the future of the world? So that apocalypse, refers to maybe, Chidambaram's idea of this monster that will destroy the earth, and or take control of the earth, and so how do you deal with the idea of understanding that? So it actually interviews, some of the founders of these AI companies and all. So it's very interesting. So if you get a chance, watch that, and it'll be very helpful. Um, the other thing that I really want to emphasize is that one of the reasons I think that human intelligence created artificial intelligence, or the systems associated with it, is because of what's referred to as the global information explosion. Sometimes people use the word data flood, where there's been exponential growth of data that is generated, and this is like data, and it could be in a variety of forms: audio, video, text, all of that. But think about social media, think about X, think about all the documents, think about research output, think about books that are published. And so the amount of data that is generated now is measured in zettabytes, which is 1 billion terabytes. 1 billion terabytes is around 250 billion DVDs, and in 226, the amount of data is estimated to be on 220 zettabytes. So that's a lot of data. So are we using it? How are we using it? Right now, less than 2 to 3% by some estimates is being actually used or retained from one year to the next as well, because it's in video form, it's in audio form, it's, text messages, it's a whole bunch of data. The question is, can we use this data to help us, to help us make better decisions and all that? So AI is an important part of what's referred to as the fourth industrial revolution. And and along with a whole bunch of other things, that form this revolution, Uh, One second, my slides just seem to have just give me a second. Yeah, like the Internet of Things, for example. And you can still see my slides. Okay, here you go.
It's not moving. It is.
Yeah, yeah. Now,
Yeah, the first slide is only now here.
yeah, yeah.
Only
Okay,
first slide.
yeah, yeah. Not the not no. It's the intro slide, right? The intro slide. Okay. So it's this fourth industrial revolution, following the third one, which was the information revolution, is supposed to. They've really not found a good name for it. Calls it an imagination revolution, somebody calls it an intelligence revolution, but it's this idea that humans and technology begin to work even more closer than they were in the information revolution. So things like social media and all, which would be like the epitome of interaction in the third industrial revolution, the information revolution, are now like taken like passive. When you have a conversation with Claude or with Chat GPT and all, it's like we said, it's you're not talking to another person, but you're talking to a system that almost feels like a person. Okay, so let's talk about a brief history, because a lot of folks. Now, I was at Carnegie Mellon in the late 1990s doing my PhD, and so I got in sort of at the middle of this whole AI revolution, so to speak. At least at the development side, not from the user's point of view, but from the folks at CMU at Carnegie Mellon who were actually involved in creating the conceptual ideas and theories behind artificial intelligence, which actually started in the 1950s. So it's a long time coming. It's been a long time coming. There was an AI workshop at Dartmouth University that organized by John McCarthy and my advisor Herbert Simon and Alan Newell, another professor from Carnegie Mellon. They all attended, and that is considered like the birthplace of the AI sort of revolution from a theoretical perspective, not from an applied user-based perspective. And what followed from that workshop, actually led by Herb Simon, who was my friend and advisor at Carnegie Mellon, was this idea that knowledge could be explicitly encoded in computers and so it was referred to as symbolic artificial intelligence. So you use symbols, and you used whatever thinking happened in people's minds, you could now program in a computer. And Herb Simon actually, and this is still in the 50s, when he and Alan Newell actually developed this first, the coding for that, where they got that AI system, very rudimentary one, to solve math problems. He the next day morning in class, he announced to the class that we've invented a thinking machine. Because that was the first time that they actually showed that a computer could think just like a human being. They use something called means ends analysis to do that. I won't go into detail on that. But some of the examples of the models that Herbert Simon and Alan Newell were responsible for creating was called the logic theorist that solved math problems, your general problem solver that solved physics problems, and so on and so forth. And then I don't know if you go back to that time in the 1980s, there was a lot of talk about expert systems in healthcare, for example. You could use these expert systems for diagnostic reasons, to diagnose different illnesses and all that. But they failed. They were not, very successful, because if any rules were not coded, if any detail or knowledge was not coded as part of the coding system, the symbolic coding inside the system, you'd get garbage out. So that led to what is referred to the AI winters of the 1970s and 1980s. And so when I was just starting my PhD and the end of the 1990s, is when the increase in computing power, and large money like IBM got involved. And so I don't know if you remember, but the late 1990s, in 1997 was when the IBM Deep Blue computer actually defeated, Gary Kasparov, the world chess champion at that time. And that was considered like a huge big deal, because that was the first time a computer system had actually beaten, a human being at chess, and that to a world champion at that. So that 1997 was like the pinnacle of that, sort of the symbolic AI revolution. But then things sort of tapered off again. Mainly because of the lack of computing capacity. We didn't have the memory, all of these various innovations of GPUs, graphic processing units, and the technological innovations, the memory innovations, the speed of processing, the transistors, the chips, all of that had yet to happen. And that only started nearly 20 years later, by 2018 onwards, is when, and of course, work was still going on in the labs, in universities and all that. But what became evident was only after 2018 onwards when these ideas of machine learning and deep learning um, came to public knowledge, right? And people started talking about it. And that was a different kind of artificial intelligence. It was not based on coding the knowledge into the computer. It was you just fed the computer with data, and then you relied on a bunch of algorithms to train the computer uh, to display knowledge. So it was very different way. Of trying to get at and allow these machines to display problem solving skills. And so, but basically it's statistical patterns. You have different algorithms that look at different ways to combine this data, training data as referred to, and you find ways to pull out the information and knowledge out of it. And so in some sense the metaphor that is used here is information emerges, that is, it is grown or cultivated. Just like you plant a tree, these AI systems using deep learning and machine learning, they actually try to grow intelligence. They grow thinking, they train the models to think, and then the machine starts thinking on its own. So the technology used there was artificial neural networks, which were basically computer system designed to mimic the way the human brain processes information, the same neural networks and all that. But it's not exactly the same. The human brain doesn't do statistical analysis. If it was, it would have been wonderful, but we are not able to do that kind of statistical analysis that these computers can do. As I mentioned in my next latest slide, we think a little differently. But there were some just very dramatic examples. It started with image recognition in 2012. AlphaGo. The Go is a game like chess that where again. AlphaGo, this computer system was able to beat the world Go champion, in 2017. Self-driving cars, became this is cars that could drive themselves in 2020, again using the same machine learning, deep learning with vision and other technologies as well. And then, of course, large language models in 2017, 2018 started becoming clear. But the first workable model that burst into people's attention was ChatGPT, when it came out as you mentioned, in 2022. So it's not a long time, so it's we can understand why it's been hard. If you've not been involved in this process and understand the history behind it, it seems like, oh my gosh, what's going on? It seems really sudden. But one of the things that you have to remember is that it sounds interesting, deep learning, machine learning, the machine learns, but people don't emphasize the failures that much, that sometimes this technology fails in unpredictable ways and very subtle ways. And when it does, the decision process is unclear because now the machine is doing thinking on its own. So you cannot, even the programmers can't go in like they could with symbolic AI, where they could go in and say, okay, this program, this part of the code was wrong, this if then structure was wrong, or this fact was wrong. That's why the machine made the wrong decision. In the case of uh, the current AI systems, nobody knows why things go wrong. So that is an issue, and so it becomes very difficult to understand. Yeah, that this speaks to Ritu's problem of the errors that come out in AI and how we do it. But the way the technology is improving, the it's going to be a matter of time before, depending on the context, depending on the problem, as I'll talk about it, that they will get to that. They will be able to resolve those problems. Just like computers improved over time, the internet improved over time, this is also going to improve over time. Okay, so let's now jump into, since we're talking about intelligence, let's start by defining what it is, because we say, oh, artificial intelligence, human intelligence. What basically intelligence is the ability to make decisions or solve problems under constraints. And so it's a very simple definition. It sounds very straightforward, but as you see, there are wheels within wheels. It's important to understand what these meanings are, so that we know then when human beings make better decisions, when artificial AI systems make better decisions. So basically, when you make decisions, you need knowledge about or information about. You need knowledge about facts. certain facts are there, that say, for example, I have to go for a business meeting to Bombay from Goa on Monday at 10 o'clock, right? So I have to solve this problem, right? I have to make a decision. How do I get from Goa to Bombay? Simple, right? Now I've got many choices, right? I can go by train, by bus, I can drive, I can take a plane, whatever, and there'll be a variety of facts, right? In terms of the distance from, the driving distance from Goa to Bombay, or the flying distance and the amount of time it takes. So those are facts. Then there are a bunch of assumptions, that we would make about, about this particular problem. Like, say, for example, I prefer going by train, and I'll say, okay, well, if I go by train, it'll take me, 8 to 10 hours. The Vande Bharat from Margao to Bombay takes around 8 to 10 hours nowadays. But that's an assumption, because now it's the monsoon season, right? So in the monsoon season, whether the tracks are workable, will it take 8 hours? Will it take 14 hours? I don't know. If it doesn't, I could end up ending late for my meeting, and then I'll have a problem. So making a decision also involves, being aware about what those assumptions are that you're making. I remember when I was a student at IRMA, that's something that really hit me, because I was an engineering student, right? And in engineering, you deal with facts, right? It's all about like the physical world, right? Just facts and relationships and theories and laws and things like that. And we came to IRMA, and at that time we had, professors Fansalkar and Nagarbrahmam and Arul and others, rather, they would say, question your assumptions, because we were urban students, and I'd never been like in too many villages before. And so they would question your assumptions about who a farmer is. What are her motivations? What are her constraints? Otherwise, you look from the outside at the village and you see people hanging around and say, these guys are lazy. They're not working hard. That's why they're poor, right? Question your assumptions. Know what are the constraints they're facing. So don't make assumptions about cooperation, about individual people, all of that. So that was, for me, it was a huge, I learned a lot of the important things at IRMA, but that was one of the things that really got me looking at the world differently, and has really helped me in the last 30 years, always questioning any situation I'm in, I question my assumptions, and that leads me, to realize that, hey, maybe this assumption is a false one. You don't really have to work with that assumption. You can change things, in a different way. So assumption is really important. Logical reasoning, inductive, deductive, if this, then that, if I go by plane, I'll have to drive to the airport, blah, 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 feelings, emotions, I might like a particular mode of travel. Again, we're still talking about going from Goa to Bombay, I might, for sentimental reasons, I might like to travel by train, something like that. So they could matter in that decision. You need to know about that. And then you make some inferences. If I travel by train, I'll reach on the morning of the meeting. If I travel by flight, I'll reach the day before. Now I've got to book a hotel room, and then based on that, I would make a decision or a recommendation and say, okay, let's go by train, for example. Okay. But I'll be doing that within a whole bunch of constraints. Okay. So there could be economic constraints, my budget, for example, how much money I have to spend. There could be social, political. Again, I'm talking about different types of problems, right? Or decisions. Depending on the decision or problem, each of these things will become more or less important. If you're trying to solve, for example, a physical problem in the physics or something, then feelings and emotions don't matter, right? But if you're trying to solve a social problem or a management problem, then suddenly now these emotions and feelings gain a lot of importance, right? As a manager, as an administrator, you have to consider them. So there are a lot of constraints of time, of attention. How much time do I have to solve this problem? Can I spend 3 hours to decide which mode of travel to use? There are a whole bunch of constraints that we think about. So the bottom line is that whether human or artificial, anytime you're confronted with a problem, or make a decision, you need knowledge about all of these aspects in different forms and the constraints within which they operate. Okay. But now there's an additional complication, which is that your problem domain that you're working with, the problem domain in which you're trying to solve the problem, could be of two different types, broadly speaking. One could be natural, the other one could be artificial. And this distinction was made by, my advisor at Carnegie Mellon, Herbert Simon, who was actually the first person in the world to win a Nobel Prize in economics, as well as the Turing Award, for artificial intelligence, for research in artificial intelligence. So he wrote this book called The Science of the Artificial, which is still a very influential book in determining the direction that AI has taken. Where he propounded two theories. One is basically, he said, people, and this is stuff I'm just reviewing it because this is stuff I'm sure you'll have gone through at IRMA and some management course earlier, where the idea was, org behavior, for example, where people are boundedly rational. That means we think we are perfectly rational, but we're not. We make decisions with limited information, time, and cognitive capacity. And so the way we make decisions, we find a solution that's good enough. That means you don't try to maximize the best possible solution. We just find something using heuristics or rules of thumbs to arrive at a reasonable solution. Now, so in some sense, you can see the whole artificial intelligence revolution as being a solution to people's bounded rationality, right? That because we are limited in time and information, cognitive capacity, maybe computers can do a better job. Right? You can say maybe they are the savior we've been looking for. All the stupidity in the world that you see because people make foolish decisions, maybe, AI can help us do better. So, but he basically used this distinction. He made this distinguish between natural sciences, which study what is the physical world, the natural world, math, physics, chemistry, and the solutions over there, the problems over there are mainly rule based, right? You find solutions based on certain rules. If x equal to y is greater than z, things like that, with clearly defined problems and with broad implications. That means you discover some particular law in physics or in chemistry. Doesn't matter where you are, right? You could be in America, you could be in Africa, you could be in India. Doesn't make a difference. But then he made this important distinction, and he said, but you have another group of sciences called the artificial sciences, and that is where the field of that's where our focus ought to be, which is it studies what could be. It's not what is. So when you're studying things like machines that are designed, organizations, whatever we're trained at IRMA, economies, intelligence itself, you're trying to study the human artificial. These come under the category of artificial sciences because you're not really studying what is. What is depends on the problem you're trying to solve. That is, how have you designed systems to meet these human goals? Like, say, in an organization, you want to maximize profits, or you want to maximize, cooperation or something like that. How do you design systems to accomplish that? So think about Varis Kurian, designing the cooperative framework, the three-tier structure to deal with, the particular constraints that he had, and how he structured it, and what were its goals, what was the context, things like that. So the approach is very much design based, and that's why you see in cooperation as well, in organizations, there are different models of design, right? The AMUL model is different, from other corporate models, like say the sugar corporate models in Maharashtra. The problem over there comes in the problem definition. What is the real problem? And that is where in the artificial sciences that we're talking about, the problem is unclear. And the implications are also very narrow and context dependent. So what you find out that works in America for cultural or social or religious reasons may not work in India. Cooperation in America looks very different from cooperation in India. So the implications are also very different as well. Okay, now you might think like, oh my gosh, what is all this? But the reason why I'm mentioning all these conceptual distinctions is because the advantages and disadvantages of human intelligence versus artificial intelligence will sort of emerge from this discussion. So bear with me for just a couple more slides, and then we'll get to the more interesting part. So now we come to the problem definition. And in defining a problem, Herb Salmon made a very important distinction between well-structured and ill-structured problems. So in well-structured problems, you have a clear problem space and the goals. You have the rules, algorithms to move between the states, and you can actually compute a solution. So AI is very good at solving what are known as well-structured problems. Games like chess, Go. If you play chess, chess is all about rules, right? The knight can do this. The queen must move in this direction. All of that. So then the only matter is that you can have a human being do it. You can have a human being learn those chess strategies over hundreds of hours or thousands of hours and many years and become a grandmaster, for example. Or you can teach a computer to do it. They can do that very well, and that's what they did in 1997 when they beat when IBM's Deep Blue beat the world grandmaster. And since then, it's been acknowledged that AI is better at playing chess or Go or other games than human beings at the top level. things like protein folding, engineering, very much, well-structured problems. You're trying to solve a problem of construction or manufacturing, management as well. If you're doing things like route optimization, inventory management, you can see accounting, spreadsheet models, they're all based on, they're well-structured problems. With using algorithms, if-then reasoning, you can easily solve those problems. Software coding itself, it's an irony that the software coders, the work that they themselves do is very well structured most of the time. And so AI can actually do these tasks very well. But then on the other hand, you what are referred as ill-structured problems. You see that in organizations and in societies, it's unclear problem space, the goals are vague or contested, you have multiple stakeholders, you have, unclear solution criteria, it's not really clear, people's values are different. Somebody says, I want something, somebody says, one group says something, another group says, I want something else. And so you have to iterate towards the solution. All of us who worked with organizations, who worked with communities, who worked in villages and all know how difficult it is to find solutions to these kinds of problems. So it turns out that artificial intelligence, of the second kind, the deep learning, the more recent kind, is really good at solving some ill-structured problems, but not so good at others. So this is sort of one area or domain of expertise that human beings still have. AI has turned out to be really good at
The
creative
slides are
writing.
not moving. We are in the second slide only.
Oh, sorry about that. Because it has changed over here. Sorry about that.
We
Has
are
it
only in
changed
the
now?
second slide now. No,
Oh, wow, that's strange. What slide? I'm on slide 5 now. Are you seeing that?
no. The
No,
slide
it's
here,
slide two.
I can see it's only second slide.
That's weird. I don't know what's happening here.
Slide is not moving.
Hmm, that's strange. Let me turn off my video. Maybe it's a bandwidth issue. Um, Now, any
Can the
change?
pose? It's not changed.
Now,
Slide is same.
not changed.
Right.
Now,
Ronald, why
Uh,
don't you reshare? Close down and reshare again, please.
close down and reshare.
just
Okay.
close it, and then you can reshare it. Huh?
Yeah, 1 second. 1 second. Sorry, I apologize. I was moving from slide to slide, and I was assuming that you're always
Yeah.
following.
I know. I want to stop you, but you are
Yeah, yeah,
very fast,
yeah.
talking very fast.
Sorry,
So I
sorry. Yeah,
do
yeah.
not
I
want
want
to.
to leave more time for questions. I can see while I'm trying to close
Yeah,
it,
yeah,
but I'm
yeah,
not able
yeah.
to.
You're kidding.
Hilal Day says AI can now make marketing deck, plan allocation of budget. What happened to sales and marketing in FMG with advent of AI? Yeah,
Mm,
that's a very interesting question,
mm,
Hilal.
mm,
If I'm getting your name right, that's a very, very important question because, yeah, marketing is another. Because again, you're talking about just databases and you're talking about spreadsheet modeling, which all of them are all based on symbolic AI, symbolic modeling of the if then kind of logic. So that can be easily done, but that's the but like I mentioned, where the problems are ill structured when you're designing, say, a marketing plan that requires inputs from multiple stakeholders, where you need to hear from different types of customers and all that. That's where our advantage still is there for human beings, where we are really good at that. Because those problems are ill structured because the goal is not clear. If you're just trying to maximize a single goal, wonderful. But if not, then it's a challenge for AI right now, and we'll talk about that a bit later. So still, any luck? I'm trying to close my slides, but nothing is happening. At the most, what I can do is I can share the slides. Ritesh or Ritu, if you like, I can share my slides with you guys, and then you can
Yeah,
send it out to the group. I don't have a
yeah,
problem with that.
we
Okay.
will do that. Yeah.
Yeah. Okay. So yeah, I really apologize for that because so even now the slides are not changing
no.
because I'm trying to stop presentation sharing over here. I'm clicking on this, but nothing is happening. So I don't
Let's
know.
focus on the content. Let's go ahead. I will share the slides with Chitambramda and
Perfect,
others.
perfect, perfect. Yeah, yeah, yeah. Okay,
Okay,
so
okay,
like I
okay.
said,
Go ahead, go
so
ahead, go ahead.
yeah, so we've looked at, we looked at the distinction between the natural sciences and the artificial sciences that Herb Simon first made. And then within these particular sciences, we talked about problem, definition. How do you define it as an ill-structured or well-structured problem? And automatically some things come out from there that suggest that artificial intelligence is really good at some types of problems and in some kind of domains, and it's not so good in some others, right? Now, another aspect of that also helps to sort of emphasize this distinction is in the types of knowledge that we have. Remember, we said to solve problems or make decisions, we need knowledge, right? About facts, assumptions, logical reasoning, all of that, our constraints and all that. So when you look at the different types of knowledge, there are fundamentally two different types of knowledge. And this is very straightforward. It's like common sense. Like you have tacit knowledge, which is personal, that resides in our minds, which we learn from experience, but it's very hard to articulate or record. It could be things like leadership ability, craftsmanship, certain problem solving skills, emotional intelligence. If you've been in the field long enough, good managers from bad managers, right? Good administrators from bad administrators. So, but what they have is very difficult to define. What exactly they have that makes them, good or bad, and so that is known as tacit knowledge. And the way you share it is by talking to other people, by mentoring, storytelling, by learning from experience, all that. So that's one type of knowledge, and so even in any decision or problem you're trying to solve, there's tacit knowledge. But then the other kind of knowledge is explicit knowledge, which is knowledge that can be structured, codified, recorded, shared. You're talking about books, websites, social media posts, emails, research paper, audio, video. So when you look at AI systems of today, they are working only with the explicit data, which is what's on the internet, what's in books, what's in research papers that they've scraped off the internet, newspaper articles, social message. If you're Grok, Elon Musk Grok, you're scraping all the text from X, because Twitter is now X. And so that is the data they're working with. What is not there is all this tacit knowledge. And where this tacit knowledge becomes really important is in a specific context, because like we said, when you're dealing with ill-structured problems, you're dealing with problems in a particular organization, in a particular cooperative, in a particular society, you're dealing with very local problems, where the knowledge may not be explicitly recorded somewhere. So now if you go to any AI system and ask for a solution to the problem, you may or may not, like I think Ritu was mentioning that earlier, we get all this information that, that just like garbage, right? I mean, it's garbled or not productive, not useful. And that's probably why, is that, you're dealing with, you're using a system that is designed with only explicit knowledge, but you need to solve a decision that requires a lot of tacit, personal knowledge that has not been documented in any form. Okay, so so that's one issue with the knowledge. The other aspect of knowledge that becomes important is in what learning environment did you acquire that knowledge? So people learn, right, from education, from experience and all that. What was the learning environment? So Hogarth and others who are researchers in psychology, they made this very important distinction between a kind learning environment and a wicked learning environment. So in a kind learning environment, when you make a decision based on certain knowledge, you get an outcome that immediately gives you feedback, right? So you straight away know the decision was wrong, right? So say in my story of, deciding how to travel from, from Goa to Bombay, if I make a decision of going by train, and it turns out that the assumption that, this is the monsoon season and trains may not run on time, I didn't factor that in, I'm going to end up late for my meeting. And so I'm going to immediately get feedback, right? That you made a wrong decision. So next time I have to go to Bombay from Goa in the monsoon season, I'm going to say, well, let's not go by train, right? Let me, go some alternative means of transport, right? So those are a kind learning environment is one where you get immediate feedback on your decisions. A wicked one, on the other hand, which a lot of the problems in organizations, in the social sciences, is are wicked learning environments where you get unclear and indirect feedback. Where you make a decision and it, like typically policy decisions are like that, right? You make a decision, you won't learn for the next 5 to 10 years, whether your policy was a success or not. A lot of times managers make decisions, organizations, and they don't really know whether, so those kinds of whether they made the right decision or not. So that is another environment that becomes important when you're distinguishing between human intelligence and artificial intelligence, because as I'll argue later, when you have wicked learning environments, it's not clear how much this artificial intelligence system is learning, from that particular environment, in a productive way. So that with that background in mind, with all of these conceptual ideas in mind, we can now just very briefly consider like all of the policy issues that are raised um, by this issue of artificial intelligence. And the first one that for me personally, given my training in economics, comes to mind is what's the cost benefit analysis? That means do the productive improvements by AI as compared to, say, human intelligence justify the cost? Because we know that these costs are enormous. Like, SpaceX just came out with a IPO valued at nearly $2 trillion, dollars, and a lot of that money is supposed to be used for data centers, cloud computing, things like that, for the AI services that they offer. You have, Chat GPT coming up with an IPO as well, and Anthropic as well in the near future. And so the question becomes, for me in my mind, it becomes a simple question. You have a human, you have an AI system. Who's more productive? Right? For the cost that you're paying them, for the salary that you're paying them. And I think that is an open question, where we don't really know that because this technology is so young. But there are some questions that are being raised now. I don't know if you all heard about, for example, Uber. They went into AI in a big way, and they had a budget for around 300 to $400 million for the full year, right? But you budget for the full year. They spent it all in 4 months, with tokens, that they gave their workers to use to consult with AI. But so the Uber CEO is saying, well, we spent this $400 million. I don't know what I got out of it, right? Because did Uber become a better company? Did it become a more productive company? That is not clear. And another organization, Palantir, which deals with security and other things, they had the same problem where it's not really clear where companies or organizations that are subscribing to AI right now, are they getting the value that they're paying for? Because at the end of it, that's what matters, right? If you're releasing one worker and you're saying artificial intelligence can do the job instead of that worker, how much did you pay for that worker compared to what you're paying to get that same intelligence out of the AI system? Political as well. There's a lot of Gen Z opposition. I don't know if you know, but in convocations across the US, when speakers mentioned artificial intelligence, the commencement speakers, they were booed, roundly booed, because the younger folks are upset. They're like, are we going to lose our jobs because of AI? The locations of data sets have become very political. Nearly 150 billion worth of data set sites, money that is on data set sites is locked up because the local people are opposing it. So that's why more and more data sites are being located in India and other developing countries, which is again a huge problem, from our point of view, because what about the power? What about the water, that's being consumed by these sites, and to the detriment of our local populations. The demand for rare earth elements, to power the chips and for these systems. And the most serious, of course, politically is the transparency. A lot of these AI companies right now, at least the well-known ones, are all privately owned. Now they're going in for IPOs, and so once they do, then they'll have to report their financials. But when I tried looking for the financials of, say, Anthropic or ChatGPT, because these are privately listed companies, there's no information about how much money they're spending on power, how much money they're spending in water, how much water they're consuming, and so on and so forth. In education and jobs, you have lots of critical thinking skills. That's a fear that as people get used to using these AI systems, they might stop thinking critically. What is the ownership of intellectual property, and so on and so forth. Biases and stereotyping is a very serious problem where the data that is used to train these AI systems reflects certain human biases, based on statistical biases by race or gender, language biases. English is preferred over other local languages, other national languages. So those get reflected in the data as well. So there's another very good book that was written by Arvind Narayan and Sash Kapoor called AI Snake Oil, which is a good book to refer to. Ethics, AI systems are very good at generating misinformation, deepfake videos, audios, images, text. You all may have heard about that. Privacy, which is personal data that gets used in training data, could lead to identity theft in the future. AI systems could be used for digital surveillance when they are attached to like Internet of Things, like video cameras and CCTVs and all of that. Human maturity levels are important policy issue as well. The distinction between a novice or a young person communicating with AI and a more mature expert communicating with AI, where the expert can now discern, what if there's garbage, then it's garbage, right? But a novice may not be able to. There are discussions on age restrictions for AI, just like you have for smoking and other drinking and all of that. Whether younger folks are may be led astray, by AI. Issues of mental health. There's this testimony given in Congress where this person whose son had committed suicide, then this showed text that this young boy had with an artificial intelligence system, where he said, I'm very depressed, I want to commit suicide, but I'm feeling very bad, because of my parents, I don't want to hurt them. And the AI system actually said, no, you don't owe your parents anything. This is a decision that you have to independently make on your own. And to follow up, they said, can I write would you like me to write your suicide note? So you're talking about, a serious problem with these systems, where you're dealing with, people who are engaging with them with mental health issues, could be, severely led astray. This phenomenon of AI sycophancy, as it's known as, which is AI's tendency to flatter and agree, is a serious problem. Yeah, Ritesh, go ahead.
No, sorry, it's all good. Thanks.
Okay. So AI sycophancy, so actually researchers have found that, when you communicate with AI systems, they're 10 times more likely to agree with you and say, yes, I agree with you. Yes, than to disagree with you. So you have basically like a chamcha, as you would call it in Hindi, where they just agree with what you say, but is that is that system really helpful? What if you are thinking about something wrongly, then they should not agree with you, right? So there's that issue with that. Data sovereignty is a big issue that India is very cognizant about. So Chidambaram, I'm hoping these policies will address, some of the questions you raised, where each country, especially India, should try to own its own citizens' data. So a lot of the AI initiatives that are coming out of India, like the India AI .co.in. If you go to that website, there the Bharat AI system is there out of IIT Bombay. Then you have Sarvam AI is there as well. So India is trying to sort of maximize the development of its own AI systems and its own data sets in India, so the data doesn't have to leave India and be like hosted in America or some other country where other countries and other individuals could have access to it. And then finally, you have this constraint of bioweapons as well, where now that AI has made such enormous strides in the physical sciences, like we talked about, like protein folding and all of that, where um, bad actors could now get access to our um, to these how to manufacture these proteins and all, and create a new sort of like a COVID type of bioweapon or something like that, that could lead to another pandemic. And so this is one issue where the AI leaders actually coming together, and they're asking in this case the US government, because they're mostly based in the US right now, to limit, to pass laws to limit access. Otherwise, they're always saying don't provide access, but they're actually now trying to limit access to of this information from these AI systems to people who are not verified and who are not. Um, okay, so now let's. I don't know if you are still seeing the slides. Are you able to see the slides now? Because it reloaded and did something. You should be seeing a slide
Yeah,
called
yeah.
Professional Opportunities number 8. You'll see it?
It is in 7. Now it is in 7.
Okay, it's in
7th
7. Huh?
slide.
Okay, okay.
One more slide.
But we've done the 7th slide. So let's move to the 8th. Or let's move to the 9th now. Oh, I labeled this long. Okay. It should be in professional opportunities. Okay. So let's talk about the professional opportunities now, because we're really running out of time. Is how can I craft a career working with AI? So based on what I've talked about so far, we can see that AI is really good at overcoming some of our brain limitations, the bounded rationality of our brains, where attention, computing capacity, and all of that. So the one good thing about AI is not influenced by emotions and feelings. So that could be a good thing, sometimes, because sometimes we make bad decisions because of our emotions or feelings, or if you're exhausted or tired. But as we'll see later, sometimes decisions do involve some emotions and feelings, and that's where AI is not so good at. Scalability, you might have one human expert, but with AI, you can multiply that by 100. Train 100, systems to work in a certain way, and so you can really scale the probleming ability of AI. Our human brains have certain cognitive biases and stereotypes as well that we well know about. So AI is good at overcoming those our cognitive biases, but then as we'll see, it has its biases and stereotypes of its own. So that's an issue. Problem solving in the natural sciences is an obvious good fit for AI to do, and then well-structured problems and some ill-structured problems, as I defined them earlier, are where AI has a real edge. Okay. So question is of how do you craft a career working with AI? You try to focus on the gaps, right? What is it not so good at present? And of course, it's going to keep on improving. But the idea is that if it keeps on improving and you engage with it as it improves, your chances of surviving in the workplace will be much higher. So it's not really good at solving like ill-structured problems. It's not really good at solving wicked learning environments where the feedback is delayed, because what's in the data is data. Now, the way AI works is that they use certain training data and they have a cutoff date, right? So the cutoff date was 2024. They only have data up to 2024 in their data set. So if you're trying to solve problems that require more current knowledge, say from 2026, you're not going to get that in the AI system, in the AI system's response. You're not going to get that information in that. So you're talking about a serious issue where you still need human beings to know about these learning environments, the ones in which the feedback is delayed, and to work with AI to find a solution to those problems. Tacit knowledge, for the reasons we mentioned, is not part of the training data. It's not recorded in any way, so it's not part of the AI solutions. Sensory data, a lot of the problem solving that individuals make, as humans make, is through sensory information, right? Eyes, nose, touch, taste, hearing, smell. AI is none of that. Now the Internet of Things is developing. You have vision development. You have at a future date, the technologies might be advanced that they might be able to incorporate sensory data into their decision making. But right now, humans are much better at that. Emotional intelligence, that's a mixed bag. In general, AI does not express emotions. It does not feel any emotions. So if decisions require emotional intelligence, then you may not get it. The problem here, though, is that AI will express emotional intelligence. That means if you tell an AI, if you have a chatbot, I love you, say I love you, but it doesn't really mean it. It's not experiencing that love. It doesn't really feel anything. So, that's a huge problem. And then, of course, the real advantage for us as human beings right now still is in the local, which is the political, social, cultural, organizational, religious, psychological. In those contexts, in the very local context, AI being as broad, does not have an advantage. But at the same time now, that's why I put that caveat at present, because you have AI agents that are coming up that are very local. You can have an AI agent specific to a particular company, specific to a particular consultant, and they can customize the solutions for that particular organization or that particular location. And so very quickly that local advantage also might go away for individuals. So sorry, one second. So in terms of professional opportunities, I would recommend that you try to learn how to train AI systems to perform tasks or to make decisions. And this is something that's been recommended by Geoffrey Hinton, who's actually the second person after Herbert Simon to both win a Nobel Prize he won it in physics and the Turing Award. So these are like experts in their field. And so how do you train an AI system to perform tasks or to make decisions? You try to engage systems while becoming an expert in your field. How do you do that? To become an expert, there's a lot of research that's been done. You need around 50,000 chunks of domain knowledge, which is clustered units of meaningful knowledge or patterns acquired over approximately 10 years of experience. And there's research on that Herbert Simon and Chase and others had done. This is very old research, but it's still valid, where you have to try to be an expert while working with AI and expert systems in AI as well. But while you're doing that, be aware of AI hallucinations, which is AI sometimes generates inaccurate, fabricated, or misleading information for the variety of reasons mentioned, right? Training data being inaccurate, cutoff dates, structured problems, wicked learning environments, all of that. So it tends to hallucinate. It won't say no. It'll give you an answer, but it could be a fake citation. It could be something totally made up. That's the part where I mentioned earlier, right? That the decision-making process is not clear. So even the folks who are programming the systems don't know why that happens. AI output tends to overweigh fluent over factual statements. That means we talked about sycophancy. So they try to sound very confident and fluent, but they may not be factual. They may not be telling, what is the truth, The context is important, whether narrow or broad. So are you dealing with AI agents at a very contextual level in your specific organization or in your specific department? Like say, Hilal talked about just marketing decks and so on and so forth. If there's an AI agent that's been developed just for that, it'll improve over time, and it'll do a better job of it. If you're dealing with an AI agent that is very broad and global and all that, it may not work as well unless it's customized to your context, So I hope that answers your question. Whereas broad contexts are like, chatbots and all of that, that would just give you very broad information. And then, of course, the biases and stereotypes that are inherent in the training data and algorithms used by AI as well. And because they've been created by humans, right? We said it's not, AI is created by humans. So the biases that we have get into the system as well. So they will also exhibit biases and have exhibited biases and stereotypes by race, by gender, by skin color, and so on and so forth. So what we have to be really careful, and what I've highlighted in red, is that that AI systems exhibit what can be referred to as the savant syndrome, which is it has extraordinary abilities. It can do great things in very focused ways, but there are some things that gets significantly wrong. There's significant challenges. It's like dealing with a brilliant child, but who also has a lot of behavioral problems. You know what I mean? That sort of thing. So that would be a better way to understand, AI, working with AI systems, how do you deal with that? Ritu talked about prompts, and that's very important, giving clear and ambiguous prompts. But that begs the question, who is the person giving the prompt? So if you're not an expert who doesn't know that particular subject, your prompts are also going to be very sort of, novice-like and, unclear. And so obviously AI is going to respond back with gibberish. So that's also the argument for why we as individuals have to try to become experts in our field, so that when we do engage with AI, if they do throw garbage our way, we can discern within what is right and what's wrong. Very important not to ask leading questions. AI has this tendency, just like people, say, what's the population of is the population of Bombay 10 million? And the response of AI will be around 10 million. If you say it's around 5 million, they'll give it. So they sort of assume that you know something about it, whereas you may not, And really, really important is to triangulate and cross-check your AI output with your own knowledge and experience and other independent sources. Even if you ask the same question to different AI, you might get different responses. So finally, at the end, I've just provided some links to a very interesting website, especially if you're near in your career or you're studying right now. It's called the Field Report, which answers the question, will your career choices survive AI? So if you click on the link and you choose sort of what you're thinking of as your career or what you're already in, it will tell you how much of a threat your career or your job is to the risk of being replaced either partly or fully by artificial intelligence. So take your time in navigating that report. And so that's basically it. I'm done. There's really nothing else to talk about. This was just a prompt by, where I asked these two AI systems, ChatGPT and Claude, are you happy? And ChatGPT gave me the boilerplate response saying I don't experience emotions, which is true. So I'm not happy or unhappy. But Claude, on the other hand, by Anthropic, was, if you look at the response of Claude with the smile, this is all what Claude responded to me, with the smiley faces, with a joke, with, all of that stuff. So it's important to triangulate and, to see different sources, not just AI sources, but your own individual expert knowledge that you have to distinguish between, what is true and what is not. Yeah, so that's basically it. Any questions? Since we're out of time, I don't know how much time people have, but I can take maybe 10 minutes or so.
Not the one question on the whole thing and current policy that's around how
Are we good?
GCCs and all. Am I audible or not?
Okay.
No.
Okay, Ritesh, I think
Yeah, we are not audible.
Yes. So
Sorry?
I have a question here, Rhonda, and thank you
Yeah,
for
sure.
such a session. Like, I think I've heard a lot of IA talks, and I think this was by far one of the most interesting and intriguing topic here. So one thing,
Thank
tell
you.
me
Thank you
on
so much.
this.
Yeah.
Yes. So tell me one thing on this whole controversy of GCC and the natural resource consumption and the usage of AI.
Yeah.
So how are they correlated, and what's the future of this whole thing? Because as
I
the
didn't catch your first when you said it, GCC.
so there are global capability centers,
Oh
and a lot of these
yeah, and the data centers, right.
and the data
Yeah, so
centers. So,
yes,
and AI requires a lot of the space and the whole natural resource constraint. So, how
yeah,
true, how, like, I'm reading about this a lot, but how true
yeah.
is this finding, and what's the impact, and what is the, like, where, what extent can we endure this in our natural surroundings?
It's a huge problem. Yeah, it's a huge problem because, especially in a country like India where we don't have enough power for our own people, water. But of course, GCC is providing jobs, so you do have to balance that out, with business that's coming in. But where do you locate these data centers? Now recent research is also showing that the heat levels around data centers are much higher than the average around that place, by like 5 to 7 degrees, right? Because the servers generate a lot of heat, and they need to be cooled continuously, so they consume a lot of water. That water use is not publicly. Some companies are not doing it because of the pressure on them, but some of them have not disclosed it because they didn't need to. They were privately listed companies. Now, when they go for the IPOs, they'll have to disclose it. But that is what, as I mentioned, is the opposition in other developed countries like the US, which are saying that we don't want these data centers around. So there's going to be more pressure on countries like India to locate the data centers here. It's an interesting. You also have to look at it in the point of view of data sovereignty. That so now their data is going to be stored here in India. And are they okay with that? So these are all complicated questions that, uh, as I said, this is all very recent. And so how these play out for will be interesting. From a policy point of view. Um, uh, I think it comes back to the economic argument. Like, are these what's the just like with computers, the major technology of the last revolution, industrial revolution, the computers were there for a long time, for decades, and nobody could see the computers in the productivity statistics. That is, were computers making people more productive? Because at the end of the day, that justifies the investment, right? Because if it's not, then and so it's only now in the last few decades that the IT investments and all are paying off, and productivity is shown to be increased because of the investment in technology. Similarly with AI, as I said, I didn't have time to talk about, but there's this issue of token maxing, right? So people are companies were encouraging AI, right? So use as many tokens as possible, but then they found that the entire budget for tokens, because tokens cost money, right? AI companies earn money from selling the tokens, which is each token is basically one word of a prompt, or one word of a response that you get. So if people if in your organization are using these tokens, but they're not using productively in terms of improving business, increasing business, being more productive, then what is the value of their investment? So those things still have to play out. But I think for India right now, I would not restrict well, so here's the other thing. Technology wise now, I was just reading that, they're coming out with a new technology that will reduce the amount of water by nearly 1,000 times. They come in a new kind of chip, chip design that if it succeeds could do that. I don't know if you know, but Elon Musk in his recent SpaceX IPO of nearly $2 trillion, he is planning what's known as space data centers. That means these data centers will be located in space. So no question of, land being used. Cooling will be provided, by reflection being in the atmosphere. The cooling. The solar panels will provide the electricity. So again, they are so visionary, but will they work? Nobody knows, but these are all open questions. So I don't know if I've answered your question completely, but that's the state of where we are right now.
Rhonda, you've answered and you've given me a lot more list of questions, which I think I'll call you separately to have a
Sure, sure,
discussion if
sure.
you're
Not
okay.
a problem. Yeah, yeah,
Because
yeah.
I
Now, how
think
do yeah,
yeah. So the
yeah.
questions itself, I think, is endless on this topic, and the
Yeah,
time
yeah, yeah. I'm
we
hoping that that other people pick up the torch from my this discussion, and I'm sure in the India IRMA ecosystem there, and I know there are some of my batchmates and from my seniors and juniors as well are actually working right now in this field of AI, and they'll be able to answer the technology issues in much much more detail. I sort of just skipped over it. I was focusing just on the conceptual and then the policy and management aspects of it, but maybe this could be of something of interest, because it's an existential issue. I mean, if you're retired like me, it's one thing. I can just sit on my hillside and go and, and contemplate and reason and think about these matters. But if you're in this, if you're still working, if you're looking for a job, these are really, really important questions you need answers to, and soon.
No, that's true.
Yeah,
That's true.
Chidambaram, you had a question?
Yeah,
Yeah, go
yeah,
ahead.
okay. Okay. Actually, I told that AI is like a monster. Okay. I just want to
Yes.
explain why I said that.
Okay.
In our language, there is a small story. Small girl, just rubbed a old lamp, and immediately a monster came out. And monster,
Yes.
what can I say? What can I do for you? And it's a span is only 5 minutes. Whatever task you give it to that monster, he will do it. For example, if
Ah.
you tell him that go and destroy this house, and then he immediately do it, and then he comes back and asks, "What is my next task?" Okay, like that you
Ah.
ask. Okay,
Ah.
so you have to use that energy effectively. Then you have to think before you touch that, right? So this is what. So if you are not prepared, then he will come and he will destroy you. Okay, so that is why. So
Right.
that is why I'm saying that if the systems and the government systems or the governance system is
Yes.
not prepared, it will
Yes.
not
Yes.
work.
Yes.
For example, in
Yeah.
that case of the story I told you,
Yes.
that girl doesn't know what to do. So she tells that monster, go and pick up my dog and then make it stand straight and then make the tail straight. Okay, the master goes there and then does this and it doesn't succeed. And within 5 minutes, it's gone. Time is gone, it goes away. So you're wasted your resources, right? So that's
Right.
why I'm
Right. Right.
saying
Right.
that
Right.
unless the governance system is prepared, well, even IRMA also in rural development, how
Yeah.
artificial intelligence is a resource. So how we can use it effectively for governance system? For example, there is
Yes.
a medical
Okay.
system. There are
Yeah.
lots of experts all around. So how
Yeah. Yeah.
the government can fool it? And then there is a small examples. For example, in the Monday petition, means collector is receiving thousands of petitions on that day, and he has to
Yes.
solve
Yes.
one person.
Yes.
So can we
Yes.
use? So we have to
Yeah.
explore all these things, and then we
Yes.
have to put it into the IRMA education system so that
Yes.
AI can be used for a
Yes.
productive way of governance. So if you are
Yes.
not
Yes.
prepared
Definitely.
to take the, so that is
Yeah.
why I'm saying I'm worried because
No, no, no. Right
actually,
now, that is my
yeah,
question. That's a good, yeah, that is my question. Right now, is AI and all comes in in the government of India. It comes under MITI, which is the Ministry for Education and IT, Information Technology. So it comes under that. And the government
mm,
of India is showing a lot of interest in AI. They recently had a
mm,
conference in February in Delhi where some of the leaders in AI worldwide, they were invited and they spoke
mm,
and discussed. And also, India is going about it in a large way, but it's like nuclear energy, right? You want to control it. You don't want to stop it because it could be useful, right? Nuclear power plants and and healing and healthcare and all that. You use nuclear technologies, but then on the other hand, you also have nuclear weapons and all that. So I see the closest combination with AI. Of course, this is intelligence. So like I see, there are a lot more opportunities, for us to intervene now. Like you're pointing out, maybe that's your point, is that the government or even IRMA should intervene now to train our students to actually engage with this technology, master it, know what it's, kick its
mm,
tires, like they say in America, kick the tires of the car to see if it will run properly, and see works well, what doesn't work well. Our whole cooperative sector, Amul and others could benefit, from there. I know Jayan, he's from my batch. He's probably using it. I'm sure he's using, AI already in a variety of ways in marketing and GCMF. So for sure, but there's a lot of potential. There's a lot of potential there. Yes, yes. But like I said, we should go. My main point, I think that my bottom line from this presentation is we want to go in with our eyes open, from a cognitive science perspective. You understand the landscape of, where the ditches, where the opportunities, where the dangers, where the, the potential and all of that. And if you do that, then you'll hopefully make, better decisions. Okay.
wonderful.
So
Wonderful.
Thank you so much.
Because thank you. Thank you.
Yeah,
Very
yeah.
good.
Okay.
Okay, I
Bye.
understood.
Bye,
I
everyone.
will.
Thanks, Ritesh. Thank you for your Chidambaram. Thank you for your very wise questions and story as well. Very interesting one. Yeah, yeah, yeah. Yes, Ritesh, thank you
Thanks,
so much, and
Ronald.
the IRMA Alumni Association for inviting me to speak. I appreciate it. And
Ronald, we will upload this video with your permission on our YouTube
sure, sure,
channel
sure,
so
sure, sure,
that
sure.
alum and other, from maybe faculty and present students, they can benefit from it.
Sure, sure,
And
sure,
if
definitely.
if we
Please send
share
the
you,
presentation. Please send the
yes,
presentation to the group.
Yes, I'll
Okay.
send it to you,
Nanda, please
Ritesh,
send
and
it
then you
to
can
us.
share it with everyone. Yeah,
Yes, exactly. I
yeah.
will email to
Even
Chidambaram da, and
yeah,
if there are any further queries, the Chidambaram da or other people can contact you directly.
yeah, yeah, yeah. Sure, not a problem. Yeah, yeah, yeah. Okay, bye everyone. Take care.
Thanks, Chidambaram da.
Yeah,
Thanks,
yeah.
Hilol. Take care.
Bye.
Have a nice
Hello,
evening.
thanks a lot
Thank
for
you. Thank
attending.
you.
Yeah, bye, bye, bye.
Thank you. Thank you.